Welcome everyone to another live stream developing one of the best and increasingly popular all CPU architectures Linux distribution. Of course, here already busy all night compiling along. Today, continuing not only making our one of the best Linux distribution better, but shocking the IT industry, recurrently finding bugs. And what we yesterday did on Twitch, or started 2 years ago live on YouTube, is creating a TESTSUITE, right? Because nothing more annoying. And with TESTSUITE, I mean, of course, some packages, not all, but some like GCC have a TESTSUITE. That's amazing. But that GCC works in the TESTSUITE, I mean, not only it runs 2 hours, recently done that, I mean, depending on your system, but 17950X 1 hour, 15950X Itanium 2 hours. Yeah, that a compiler works somewhat, and then we can't even use it, right? Like, of course we should use it, and increasingly contributing upstream, we will use it more, but we cannot run hour-long tests and then we only know that the compiler is somewhat good. Also, it tests like 10,000 things or 100,000 things. I think it has 100,000 tests, that's totally amazing, but then like 1,000 failures, it's like, yeah, helps me a little. I'm not fixing all 1,000 complex GCC bugs. But much more important for us, of course, the compiler somewhat tested usually mostly works, except for MIPS. Also, yeah, we are busy. We epic thread rip here on Ryzen 17950X. And we knew this already, and it continues to be a case that GCC currently fails and internal compiler errors also for OpenSSH for MIPS. That is super annoying. Internal compiler segmentation fault. During RTL pass, yeah, so much to 100,000 tests, and at the end of the day, the MIPS compiler fails for not even that huge code. Sure, maybe complex and stuff, but not the size of GCC, the Linux kernel or whatnot. Anyway, so yeah, each time we finally want to release something and then GCC, more, I'm segmentation faulting for you. Anyway, we have some more things to fix. So I, unfortunately, with all the time up, pour here in, and yeah, GCC TESTSUITE, right? MIPS, GCC, MIPS maintained. I heard Debian might ship this, and in the end of the day, 4 months, it's segmentation faults. But coming back to our Linux distribution. So years ago, live on this channel, some 100 videos ago, we started a TESTSUITE because we want the GCC TESTSUITE is nice and stuff, helps us little, especially if it, at the end of the day, segmentation faults by compiling OpenSSH, but we want to test our ISOs, right? So we continued that. We also can make this larger for you. I only zoomed this out for the B-top view. So in our build all thing, we also so all and then test. And so that is what we have done yesterday on Twitch for 2 hours, and that is also why I didn't further work on this, because there was just like my to-do is literally 667 entries long. And yes, the TESTSUITE is nice, but as long as my to-do was 667 entries long, there's also other things to do, right? So some stuff is also already failing for, this is also, did I not move that? So what this does is, this is testing the resulting build, right? This is totally different from, sure, GCC TESTSUITE is nice, but nothing like compiling all your ISO, and then, as happened yesterday, and I came back to that, I mean, obviously that is to-do entry, basically number 1, nice to have for years, and I should have done it decades ago. I would have saved us, yeah, TESTSUITE. The only substitute for TESTSUITE is more TESTSUITE and continuous integration. And the reason is, as usual, right? Each day I work on something, embedded systems, virtualization and whatnot with our customers, and each day I find multiple bugs, right? Like basically at least one major bug an hour. That is absolutely crazy, right? Yesterday I built our new set of bi-monthly major ISOs, x86-64, ARM64, RISC-V 64, and then report, I mean, because I didn't have this full TESTSUITE until yesterday, reports came back, yeah, the the ARM, was it ARM? No, x86-64 Musel build doesn't boot because UDEV of all things fails loading modules, right? So turns out with Musel updates, mostly Musel updates, maybe also Kmod updates, like 2024, the Linux kernel module things and libraries segmentation fault when compiled with latest Musel, right? And that is the stuff, and in udev, right? And that is where yesterday I was painfully remembered, TESTSUITE, the more TESTSUITE, and what you didn't test is broken, and the only substitute for testing is more testing, and the only constant is change and regressions. Also nice merchandise in our European fashion store down below, if you want to find bugs in style. And so I scripted that yesterday. Further, I started this, as I mentioned 2 years ago, further refined it, so that is now more working. Also, right, I wanted to delete this one test, not sure what did I do here? Okay, somehow I again renamed this wrongly, apparently, because this test is not yet fully working. So that is also, I changed my mind again, actually, because we had an all architecture 36-bit configurations from R, multiple ARM, version 5, 6, big Endian, 7, ARM64, right, already 4 builds plus Clang and Musel. 36 freaking build configurations is what we can epic thread rip here ourselves overnight in an office, which is truly amazing. And we had an all thing released just last month, but we fixed so much. Basically, it's probably, I built it now all, like, because I wanted only an interim release of the 6 most mainstream architectures: AMD 64, ARM 64, RISC-V 64, PowerPC 64, 32-bit userland 4, Power Macintosh P3. I figured, you know what, we can build it overnight. This Ryzen was busy overnight. We are soon done. Let's re-release, because it was also, it was certainly not ideal that we put all the efforts, our release was delayed, and then because somehow it was not the right timing, we didn't make the biggest announcement, right? Like, basically we did make no announcement, which in retrospect, because in this week I felt we did so much, let's have this a little bit pre-tested, and somehow I don't remember what time it was precisely. Maybe it was New Year, maybe something of, or I don't even remember why precisely anymore. At that day it felt like reasonable to not make the most major announcement. Probably I thought it's maybe a little bit outdated, and I forgot. I mean, before Christmas we didn't make an announcement because it was Christmas. Like, makes no sense to make announcements and bury it in news. But in retrospect, maybe each announcement is a good announcement. Like, even if it's buried in Christmas news, so be it. At least one news site or whatever. But the point is also, it takes hours to write release announcements, proper release announcements, easily an hour. Sending it to some news sites, second hour. I simply didn't have, like, I fixed so much, I didn't have more hours of fixing this. So this is why I decided, okay, we put so much time into this, we didn't even release it, like, really, because in retrospect, it's not even clear to me anymore. So let's do it now and let's test it more, right? This is why I'm rebuilding this, all because I now want to wire all this testing up, right? We don't have the most tests yet, so basically, I said this yesterday on Twitch, or you've seen this 2 years ago. Bin ls, so all of these tests have a reason, right? I mean, and we will soon have more. It's just the basic infrastructure was some hours of scripting, especially the who build. So we have now who build tests, starting with does some simple binary work, right? Because with all the uclibc, Musel and stuff, then does shell work. Then now, new since yesterday, does mod info work or not? Like 2024, you need to test that your bloody mod info or depmod or mod probe binary doesn't work. Testing mod probe is not so easy. That is, means they all crash similar, because running in QEMU userland, we can't mod probe there or something, so unless we run it with a system. Even years ago, I made this test already years ago, because at that time rsync even crashed, right? With unresolved unresolved, or actually it was segmentation faulting. I think it was not even unresolved with function ifunc CPU runtime detection logic. Crazy stuff. I prepared here even X that was somewhat working. The testing is tricky, right? Ideally, I would want to bring Firefox and see that it loads. But the problem is pixel perfect stuff, right? Maybe it would make sense to run Firefox with some JavaScript thing and print hello world, so that to test, because running Firefox with some JavaScript snippet to print hello world is easier to continuous integration test than bringing it up. Each version of Firefox looks different. It's like testing is complicated, right? Like it sounds so easy, like I just test it. Yeah, like how, right? You need to have this infrastructure. We could render, so obviously the splash screen of Firefox is not screenshotable in a comparable way of differing each release. So my idea would be to make a simple hello world print thing, because we want to test, like we don't want to do layout testing. That's Mozilla Foundation Firefox job. We just want to see, does our cross-compiled Firefox come up on PowerPC and MIPS and not segmentation faults, which, spoiler alert, currently does. So yeah, some stuff I did here screenshotting. So some stuff we could screenshot, like for example XEV. Like I started here test. It works in principle, but not. It's like, yeah, it's tricky, right? Like how do you time your screenshot? Probably we need some sophisticated infrastructure for that. So yeah, yesterday init. So that is, I also have. So this is, they all run through QEMU user for now, for the most part anyway. Because why? Because we want next thing, right? Testing QEMU, right? Do we test QEMU more than our own stuff? Because we want to test for all cross-compiled ISOs, right? And if we cross-compile, if we epic thread rip all those ISOs here, then we want to test those that they also work for ARM and MIPS. So let's basically test some more. Let's wire up some more architectures. So because yesterday we only tested those 6 combinations, so now it's time to test more. And that is all it takes. Like this is quality assurance, right? Helps little if it builds. The Musel stuff did build, and now it's segmentation faulting. So yeah, the tests, and yeah, QEMU not the fastest. Probably we should optimize QEMU. We probably in the long term need to integrate more emulators, for example, unless we port QEMU for Itanium. So unfortunately currently we can't test Itanium unless we run it natively, which we could of course extend to natively secure shell stuff. What do we have here? So ARM64 running tested this. There's something failed potentially. I mean, maybe this was just too slow. Currently we have which are mini init.rd. So maybe that is just too slow. I have there, and so that is my summary, right? Like further crunching away, further coding away. So internal tests, that was because I think yesterday I accidentally committed the timeout for, was it that one? Timeout 8 seconds, which, so yes, this truly sucks. That is, I don't want to have the longest timeout because I don't want to wait like an hour. All right, we use the same. All right, we use it probably. This looks to me like maybe just not fast enough. Maybe we would need a scaling factor, like if you don't do this on Ryzen, to check that. For example here, so that is which architecture. So that is more scripting we need to do. It's simply not wired up. So that is ARM. So we don't have a boot image there. And that's exactly what I wanted to do, right? I knew all the other architectures. There will be boot marginalities. ARM version 5 and boot. What? We didn't build the kernel yet. So I mean the builds are still running, right? I just wanted to pre-test some stuff. I will probably also later need a which one is this? PowerPC? Probably not the kernel yet. Yeah, I built all night long. Obviously a night is not enough. Ryzen 7950X needs 24 plus hours. I only started this around 10 maybe. I actually even rebooted because previous video I now overclocked my Infinity Fabric also a little bit, because obviously the only substitute for performance is more performance. With the latest BIOS update it wasn't entirely stable. It's the only reason I touched that, right? And with stabilizing this with slightly reduced primary memory timings, but increased Infinity Fabric. It's not only stable, but even slightly faster due to 66 megahertz more 2066 Infinity Fabric. So more stuff building. We built since, what did I do? 16 hours. No, we have here, so that was before midnight. So let's take a closer look. What more tests? So we probably run already quite some user space tests. Not really sure. Do we not have? Where's our PowerPC built at what stage? And I immediately found new stuff, right? So last night at midnight already, because now we somehow, actually I should check what we do in initRD. The Linux kernel was panicking on oopsing on PowerPC 64 even with PATA legacy. What even do we do here? Mod probe. If no block devices, load some legacy drivers. This test might not be perfect. Maybe we could additionally check if there is, like there might be a host controller but no attached disk. But fact is, PATA legacy, oops, the Linux kernel and QEMU, so much to it. Because I was wondering, I didn't see it on the G5, I just the other day booted the G5 and the P3. Didn't oops there, but probably because I have disks. So probably maybe both P3 and G5 might have oops the same way if there were not any connected ATA block device potentially. I disabled PATA legacy for now for PowerPC 64. So already one potential bug fix, right? What was that I think, this is Spark. So my TESTSUITE stuff then outputs the diff, right? Here, for example, so somehow Spark 32 plus, so that is 64. So all the user space, and is that not amazing? Like you embarrassingly parallel epic thread rip that, and then you have an ISO, and like next we could even script Zool installation that will be error prone and time consuming. But I mean, that's the thing, right? Do we really, I mean, ideally we could test Zool installation. Maybe we could even mark tests like only with KVM, so that tests are only run when QEMU KVM is available, and we don't like test something for 2 hours in QEMU Spark. That are all the next steps, like to decide. So basically everything that will majorly segmentation fault and whatnot, I will add tests in the future. That is of course simple. Start like even the kernel scripting. We scripted this for 2 hours in total. I needed over 2 hours, right? So is it because it says some expect? If you are a unit testing expert and have better ideas, so for QEMU we currently use the TCL based expect, because with that we can set timeouts and send and wait for expected output. Here, spawning QEMU for all the architectures with all the necessary flags, and then expect T2 SDE, like eventually, like after latest 8 seconds or so, expect T2 SDE early user space, whatever there, with more strings, and then expect no root. I wildcard that here because we changed the string sometimes a little bit, right? So that's why we log on here on parts of the string. And like if this fully built, then shut it down with echo O for power off. It's a low level thing. We don't have much in the initRD. This is why I've done that here. And then eventually we expect reboot power down. We might need to touch that further. So that is just in it. That's what I wanted to do now, right? Do this for more architectures, because we might not necessarily be able to, or also, yeah, tset data broke something. Yeah, that's the thing. The only constant change in regressions, right? People add new stuff and then it breaks here. So what is it even, alpha? Why did this not break for the other architectures? Yeah, that is a sad thing, right? You do so much at the end of the tape. Why does this? Maybe because we updated. So I believe this intention was to enable that for Musel. But we have this now for alpha and stuff, right? glibc supplies its own sig binary. If Musel, then cd code. No, there's always one more regression, right? That is somehow, I mean, we could for the moment locally revert that. Yeah, the only substitute for testing is more testing, right? We need to be careful. That was it Neos 2 probably, right? Yeah. Mine Neos 2 T set data. And it was in glibc. Now we also removed the glibc file, so we need to have glibc. Cargo. How to fix big onion. There's always one more. Let's skip over for this for a second. I'll fix this later. Onion is big. Oops. I hate the insert key. Should remove it from my keyboard. So this was alpha, so again, it probably didn't build for the other builds because it probably came in late last night, so probably the other builds already had built tset data without that. Also need to, like, yeah, I'm a busy man. My own changes, other people contribution, the only constant is change and regressions. So RF tset data. Rebuild one glibc. And then what was a failure here? Can't reload it. Maybe we killed it here in the middle. Maybe 8 seconds are also not enough. Probably. I mean, we could make some scaling factors. So we could just add a very long timeout. I had this intentionally restricted. Also, again, if you have a better way to script QEMU, I maybe should look into the QEMU and Linux kernel testing things. What they do for testing, if anything. I mean, the Linux kernel has shockingly little testing, right? At least the last time I checked, which might explain why they have so many regressions. It's like, yeah, probably stuff is slow. We could, I know it's a unlucky 13. Let's do that again. Let's see how different. Maybe we could add a timeout scaling thing based on the host system, because obviously 17950X is relatively fast. Although this machine is fully loaded, right? Like, how amazing is T2 Linux optimized and stuff? Like, we have a load of 100. Like, since the whole night we have a load of over 100 on like more running processes able to run in runnable state. 124, sometimes even more, right? If we build all of GCC and Clang and parallel Linux kernel, then it's also 200 for all those plenty builds to build at once. So obviously without all those background load, that's way faster, to no one's surprise. It's just slowish. What we should do next, so basically also to do for the testing, right? Do we have a to do here already? Maybe scale timeout with host per cost and QEMU performance, because all the different architectures perform vastly different, as you see. So Spark or so is vastly slower than some others. PowerPC also fails in... How does PowerPC fail? This is a power... Ah, right. This is the same thing. So with PATA legacy, it failed... it oopsed in PATA legacy of... I actually commented... Oops, no, press Control C there. What did I want to write here? So I disabled PATA legacy for now. It failed with bug, unable to handle kernel data access. Whatever legacy IO code thing would do. The Gary says, wish QEMU would support some kind of configuration thing. Yeah, maybe some kind of built-in libvirt. Yeah, it's indeed. But I mean, it wouldn't help us that much, because in our case, whether we write a configuration file or supply everything by the command line, it doesn't really matter the most. So I pressed also Control C there somewhere. So maybe because... Maybe I pressed Control C there while I was navigating around, because the mini Ramless mini RD failed there. There is also something segment core dumped. What is that mod? Ah, this is... Ah, yeah. So that's the Musel. So that is a bug we still. This is what everything triggered yesterday. That year. Still need to fix this. Mod info. What do we have here? Of IO remap called early. I think this is this is a generic Linux kernel bug. Running init. So this is... Ah no, this is... So yeah, what is strange here, I need to check this with real hardware, because the day before yesterday the PowerPC build booted on a G5 and P3, so that is maybe some QEMU bug potentially. This is funny. Your machine is a CUDA based, but wasn't compiled with ADB CUDA. So the problem here is a little bit, maybe I shouldn't run PowerPC with Mac99. It does work, it's a crude hack. Maybe the Linux kernel. The problem is it doesn't make sense on real hardware. I'm not even sure if you can enable that on a 64-bit kernel. Maybe I should test some PowerNV P-series QEMU thing. So yeah, we unfortunately we need to. We probably should restore QEMU. They removed PowerPC 64 ABI 32 ABI because allegedly nobody was using it. Why are this not more? 1, 2, 3, 4. Somehow these are... I would have expected more tests. Why does this not... all sets the arch? Or did I... Or is it because I pressed Control C? Because what I wanted was wire up some more QEMU instances there. Why does... Oh, this might be generic. Yep, I need to script this, so obviously it doesn't scale. I mean, it was never a good idea to just skip over stuff that's not supported upstream yet, like 32-bit pointer, x32, x86 ABI. Also, ironically, maybe it's supported. I should actually test if the Rust compiler correctly works for that. I should simply, so I don't have a good way to disable this because we disable by architecture. So we could disable x32 and x64-64, x86-64, AMD 64, right? But we can't disable because it's x86-64 32-bit variant. So we have no means of generically disabling that package now. I mean, okay, I could either change my build all driver front end to disable that, or which might actually be the nicer thing to do. Otherwise, we could change the package code to detect this and just not like build an empty package, which might also work around it, hides this error, like not fix it, but hides this error. Yeah, there's always some more stuff to do. So yeah, now we test more things. Or do we? Risk 5. Yeah, so this all initRD, but these are important tests, right? Why do we have two? Like, first is, does this stuff boot at all? And the second is, does the mini initRD with significantly less things, like is there a bug in our mini initRD generation, which not putting in enough libgcc and so on. So we might probably, I probably want more arguments for this TESTSUITE driver thing, like maybe, this is funny that this actually was one faster than the other. Anyway, so I probably want to selectively test like user space and all system separately to cut down time, right? Like if we want to get an overview, which one is that here? So MIPS. So yeah, that simply didn't build a kernel yet. But so other stuff, so basically let's check other generic QEMU. We probably want in the future to add more flags, for example, pass down our 486 and 686 configuration. We probably should add a to-do so we don't forget. Select CPU or sync CPU, is it dash CPU with T2 arch optimization, so that we make sure that 486 stuff is actually 486. Presume it's all bash, yeah, mostly except expect, so it's basically TCL. I mean, it's also, I mean, the tests are not necessarily shell, right? So, I mean, it's not even testing for, we have a bin sh test with basically testing dash. If you mean that, but the base scripting as usual is, dash here is a funny one. Okay, we probably have, I have a list here of things. So like, let's probably go more systematically through that. Let's test alpha. Okay, the user space test path. Okay, this didn't build the kernel yet. I mean, yeah, the tests are not, we basically, so this mod info test depends on having a kernel build, right? And this test fails because lib modules, but we are, the point is not, we only break it because we test in progress thread ripping build. It's basically nearly impossible to have testing only one thing. The testing only one thing would be mod info without arguments, or with, actually ironically, mod info without arguments, segmentation faulted. It's like, you can't make this stuff up with current musl, or musl muscalypsy. But I need some reproducible argument there, because otherwise I don't want to compare successful mod info -- help text, right? So the lesser evil of this is have mod info depend on a kernel being built than comparing random chat and testing nothing, right? Because then the test is actually testing mod info being actually able to parse the ELF Linux kernel module. So alpha, what do we have here? So this looks pretty standard. That basically, did I have this committed? Yeah, so then I can delete this. So basically that should work. So we have verified that, right? We just don't have the kernel yet, so that should work. Then we have ARM. Our ARM also should -virt. Do we do that? We run with -virt, okay. Verified that. AArch. I tested that yesterday. ARM64, that I believe worked, right? That's wrong terminal. So this was just my last year compiled. Like basically all this stuff took already more than 1 day, right? Like 2 years ago I started with this, it was started to work, didn't have more time. Last year I compiled all the QEMU things, which also sometimes took half an hour or even an hour. With ARM I debugged probably easily an hour to find a combination that where an ARM kernel booted in QEMU as output. So there's always some more things, right? Okay, let's this finish here. It's really okay, that's even finished, amazing. HPPA. The user test passed there. We don't have a kernel yet. We run this with nothing truly special. Also, we had to do crashes. Like, yeah, but that is QEMU, right? Works on real hardware, but crashes QEMU. Probably, as a result, I might file a couple of upstream bugs because I will not debug. Each crashing code generation thing in QEMU. There's a limit of how much I can do. I believe this. Yeah, okay, the user space succeed. The next is, so there's a typo. Haha. Let's test Motorola 68K. We hopefully, we don't have, why does it say? Because this says NA because ours wasn't built. That is actually a fair thing. Okay, we run here. Did we have anything special? So I clean this file because I don't need to have random files. This was just my. Here's actually apparently we need that here. That is some Mac Quadra machine or whatnot. So let's add this to QEMU in here of shared. That is it correctly sorted? Yes. So Motorola 68K needs QEMU args -m. This in Quadra it's 800 or whatnot. Theoretically, we could make this depend on. This somehow didn't. Oh, this is also a typo. Theoretically, we currently build a kernel like that. So I mean, so we did this, right? Do I have the QEMU args machine with T2 kernel conf? Like if someone changes that we could theoretically auto detect that, like if it has the right support, like Mac or Atari or whatnot, and run it slightly differently. So then, so we've done that. So that's basically what I wanted to do for this video, right? Like wire up more microblaze, more architectures here, port all the stuff over, microblaze. Was there anything special? Yeah, crashes, thank you very much, welcome to my live. Can't change root into, what did we not build microblaze? We have microblaze there. Why do we not have? I mean, it is possible that I wiped a build or two. Or maybe I wiped it. Let's check, because I built some with the wrong configuration. Yeah, here, that is the wrong configuration. Yeah, Arc and Microblaze. Did I rebuild Arc already? Because I recently renamed those. Let's just build all Arch Microblaze here. So that is just single shot espresso. Of course, the people care about the most important things. Yeah, no, it's base. I wiped those builds because they built, due to my rename, they built without a package selection template. Good, Microblaze. Do we have anything special here? TTY, no, this looks totally generic. MIP64, apparently to do, MIPCell. Don't have a kernel yet, but otherwise it looks fine. What did we have here? We had dash and Malta. Don't have the kernel yet though to notice. So that was, do we have that in MIPCell? No, we don't. How do we do that? Because it's Arch MIPS. I mean, we could use an Arch triplet here. Does it? What do we have here? Arch. How do we do that? I mean, we could actually... We could lock that on the QEMU binary. What did we? That was Malta, right? QEMU args Malta. This will not just work yet. We have here arch, so that would be MIPS. We probably don't have the arch triplet in the config. Okay, we said, however, I don't want to repeat this, so it's always like, it's even some scripting glue, even if you script stuff for 20 years and stuff doesn't match the most amazingly, it matches all in the context of, it builds all the stuff, and then you add some surrounding test infrastructure, and you have even like ID and arch triplet parsing challenges. Maybe we simply use, because we have here MIPCell in, maybe we lock this on the QEMU. Oh wait, we don't set, we probably need to set QEMU here for actually MIPCell. Do we have system we have all those MIPSL systems here. So that actually we don't check that anywhere else, do we? I mean, we don't really have 64-bit MIPSL. It looks like that exists in theory, but not like even we would support it currently. So I guess we can just add, like, not to retype all of that, just add EL. And so that is QEMU, so we could maybe simply switch that on the QEMU system thing, although, yeah, otherwise we run just so that would be ARM MIPSL 68K PowerPC so that arch is just not so actually QEMU system. This should match, shouldn't it? It's a little bit there, but yeah, ideally would probably be to export the whole arch triplet there, but we don't have it there instantly available. We have the QEMU MIPSL. We have that in there already for some reason. Maybe I said QEMU2 arch, that comes from our, okay, this is how this already worked, okay. Then this worked accidentally due to our naming. Okay, fine. The more you test. So now this MIPSL stuff passes, that's amazing. And here we have Malta, that also works good. Neos 2, nothing yet. That is otherwise completely standard. This is Neos 2, okay, the user space stuff starts to pass. Neos 2, that other stuff was standard. OpenRisk also standard. How do we name that? I think we name this OpenRisk. And that doesn't work yet. Also, this OpenRisk didn't. Because it's probably UClipsy. And at least one test passes. Bin SH. Apparently empty, so probably not bin sh yet there. We could change all tests to, I mean, maybe we should. We could change each test if we wanted to. Because we have in rsync, if exists otherwise not applicable. So this bin ls. Then we don't get TESTSUITE errors. I mean, we could even have two special exit return codes for not applicable because in general not supported, or not there yet to like Itanium like NAT, not a thing, not there yet. I wonder if this is a relative symlink. It probably is, right? What was it? Open risk. Oh, this wasn't there yet. I'll probably rebuild that. Okay, but otherwise, sh. That's a relative there, not absolute. Similar. Where was it? Here probably. So bin ls and that is. Oh wait, I probably even did this wrong. Bin sh, or did I do this correct? Oh, bin ls. Okay, was it bin? Yeah, bin ls. And then we could even do that for this mod info. Bin mod info, and theoretically we could, I mean, we could add this in one conditional, but we also don't have to. We could even check that this exists. And I think I later eventually changed it to another exit code, like maybe 43 or whatnot, of not yet there. Yeah, not applicable yet. You know, let's do this now. So qemu, let's change this to 43. What other tests do we have? Okay, we have that here. I probably would want to do that globally, so that we should do this next globally. I did this here, right? And then let's change the test driver. If that is 42, then so 42 is not a thing and basically not there yet, and 43 is not applicable, not supported. We could name this cooler, but I guess for now, so what do we get now? We get not a thing, passed, not a thing, not a thing, and that fails for. Yeah, theoretically we could check there too, but there's also a limit now. We could check that the stuff is there and similar, but yeah, for another day. OR1K, so that looks good. Let's test if all the return code stuff works for like ARM64, pass. Or somehow we we changed this because we changed that. We need to change it to ARM or ARM64. Good that we tested that. That looks better. Questions there explain what you're doing. Are the lack of integration tests in the kernel, or are they not existent? I think the Linux kernel has very, very, very little testing, right? I actually I said in the beginning, right, the GCC has 100,000 of tests, and the Linux kernel probably has next to 0. They probably have some tests, but like I don't think the Linux kernel has anything like that. But the bigger problem is not only the Linux kernel, and the massively, I even said the massive GCC test suite is even a problem for us, right? Because it runs on a 1750X 1 hour, on a 1550X with QEMU, what was it, PowerPC or ARM, 2 hours. I can't run tests for 2 hours, and then it's only GCC, and then I know 100,000 tests pass and 2,000 fails. Like, what now? So I'm not interested in the fine-grained testing of GCC. Again, the Linux kernel is next to nothing. Correct me if I'm wrong. I actually should check what QEMU probably later I explore. I looked into QEMU has some testing, but I think I didn't even see anything like that. I need to, we could check now, but we wanted to. The problem is to. So as far as I know, the Linux kernel is nothing like executes the stuff in QEMU. Whatever testing the Linux kernel has. Linux kernel test suite. It's like testing guides. There are a number of different tools for testing this kernel. So now I want to challenge. Documentation provides a rough. How is Linux kernel tested? Testing project test suite to the open source community, validating reliability of the Linux kernel. Yeah, I should check what's this LTP Linux test suite stuff. Linux kernel level versus community testing to test their own code before submitting. It's like, yeah, community testing built for me. Good luck. Tends much in a way of formal test plans. So how old is that? Linux test project delivers test suite, open source community validating reliability. Auto test framework, auto designed to provide testing kernels, hardware virtualization testing, general user space. This is auto test. Maybe it's external. I would expect this to be part of the Linux kernel. Didn't see there much. Maybe they do here. QEMU. But the problem is if you need to framework fully automated testing using primary Linux kernel. Maybe they have something here. I didn't Google what other external things. Also, please check Avocado, next generation automated frameworks. Like here, the only substitute for frameworks is more frameworks. The problem is also that often test suites are just so embarrassingly overcomplicated. Like where even start looking here. This is just a scheduler for testing. It's like also embarrassingly huge Python code base. You lost me already. Like I just want. People also overcomplicate this stuff, right? I want to run some binaries, I want the results, I don't want to run 100,000 lines of Python code. So yeah, apparently there is some testing, it's just in the Linux kernel and whatever the Linux kernel, Linux Foundation does. I find this much more minimal and elegant, but fight me in the comments. So we tested that. PowerPC, I believe, did this work? Arch, PowerPC. But again, even if there apparently is some testing that few people use because it's external and convoluted and whatnot, I want to test my ISOs, right? Helps me a little that like testing the Linux kernel is one thing, like we need to test that our init already works, we need to test the kernel that how we build it works, that we built a PowerPC that works on Power Macintosh. We need to test that even the compiler works, right? So the next test would actually also be a compiler test that is difficult because with QEMU user we only run one executable, so I probably test individual things because unless you register the system wide of running other executables, you cannot just even simply like QEMU GCC because it spawns background processes, linker, assembler linker and stuff. So that's not super trivial. Maybe we rather test individual things, one QEMU thing at a time, to keep it super simple. But time will show what we can do. What was it? PowerPC is not there yet, apparently, for some reason. Why not? Can't be not all not there. Ah, right, I named this build wrong. This is PowerPC. PowerPC. This is better. Not yet there stuff. Why? Maybe this. Ah, right, this failed. I need to fix. Yeah, it's not there because we basically can continue on Twitch and fix some more things. Turns out our Clang tidy disablement needs to be further disabled for PowerPC. Mirza is a QA engineer, that's amazing. And like, if you have other best practices, leave them in the comments below. Basically, I probably should check also QEMU. I think I checked a year ago and didn't find something totally amazing there. Basically, I would be interested if some state-of-the-art test engineer has feedback for that here. So basically, we run a whole operating system, not this. 9.0. So we boot a whole system and then expect there's some strings, right? This is how I scripted this so far. So launch our ISO or QEMU with kernel. Expect that eventually our own user space comes up, and then expect that it didn't do any root file system stuff because we run it like this. We want to test booting Linux kernel and our initID works. So does our initID come up within 13 seconds? And then it doesn't have a root and gives you debug shell, and then we shut it down. And so, yeah, if you have anything better than TCL, expect, leave me in the comments below. That is the best that I found so far of automated QEMU whole system booting. Did I also, where did I, maybe I started typing and then digress. Download mirror QEMU. But with with hundreds of megabytes and millions of lines of code, I would really expect the Linux kernel to ship some integrated testing, which I think they don't, apparently some external things. Which maybe explains why the Linux kernel has so many bugs. Yeah, there's quite some stuff there. Also here, so Ryzen is slowish because it's building. What do we have there? libopus fails of DNM comp. This is, which build is this? ARM? Version 6, seriously? libopus. So yeah, each build, something else fails. No LTO ARM maybe? Let's hope for the best. Nothing like quirking, workarounding and hacking some builds in between. So they have tests here. They have also out and error stuff here. Is it even similar to ours? Out. Wait, why is this empty? That's a good start. Bad if empty. Okay. Bad if empty. Cool. So they have here even just some numbered stuff like I do. Somewhere. Maybe not there. So I mean they test some of their even IO tests, like maybe check like what do they do there. This was even this stuff. Okay, this looks even similar to my simple stuff, at least on the file naming basis. Okay, they do this with Python. Okay, I already don't like it at all. You think my tests are convoluted, like Dio, you had slide, nah, they do some stuff, fine. So that is their Python group. So yeah, I totally don't, not a fan. copy on, so that's probably maybe they also compare that. So this looks simple enough. Just I'm already. What is here? VM. They have here. What do they do here? Do they run that? So they have all tests in Python, which I'm already totally not a fan of. Okay, they do here prompting and stuff. Yeah, I don't know. This is okay. They send and wait here, similar to expect. I mean, I have to say I like this old-fashioned expect thing more than this modern hard-coded in Python stuff. It's what it is. So they apparently boot here something. Not saying. I mean, anyway, at least they test something, which is better than nothing. What is that here still? DNA. So LTO did apparently maybe not help. Lib opus. Link time disable. Okay, this was not LTO, which that is bizarre. Maybe disable that for. Oops. Maybe this code is just complexly confusing. Arch, not ARM. Then enable that maybe as a workaround. That should work like that, right? We are in ARM version 6. Mostly work on web apps though. Pretty buffed that something as expansive as things does not have any form of standardized test. I mean, they apparently have some standardized external tests, but I mean, the last time I only looked into Linux kernel sources, didn't even see much. We could actually double fact check that. I'm also baffled, right? Like if I would have 200 million funding like the Linux Foundation, I would have, I mean, yeah, they have external stuff, but I would expect Linux kernel some form of make check to do some make checks, but yeah, the Horizon is loaded with you. Okay, this, yeah, it's a hack to disable this new machine learning stuff, but like I'm not debugging what breaks in the compiler, right? So apparently, go figure, 1 million tests in GCC for 100,000 tests, I believe for GCC, 100,000 tests for G++ or whatnot, plus minus give or take. Some for ADA, some for Objective-C, some for other stuff. So I believe it was kind of 500,000 tests and still doesn't build for popular ARM architecture there. Yeah. So did they have anything named test here? Okay, tools testing is like, nah. So they have there some self-tests which extremely minimal. Whatever they do there, I don't know. I mean, also this is perf tests, which also do not look the most exhaustive. Yeah, whatever these tests do, some is also self-test for PCI and VDIM. But it's not like running QEMU on there's yeah, whatever the test there, it does not look to me like I've not seen run QEMU on, and there's RCU torture. But it's not like testing this with QEMU that it puts or whatnot, so I mean I'm pretty underwhelmed by all of this, to be honest, but also this other tests like this auto Python stuff, it's like, yeah, anyway. Certainly people can say this to this shell scripting, but I find it much more readable and so on, but that's another thing. So what was with our PowerPC testing? All right, we didn't, okay, this probably, okay, we didn't even had a Mac 99 thing here. So I have that. We also have Power NV. We could check, but all right, we anyway need this. You know what we need? Cool, we can actually, now that we changed that to use the QEMU name, we can actually any system. Oh, this also didn't match. Or does it not have little endian? Why is here not? How was it with endianness on? Okay, we can't, and we also named this wrong. Now that we change this. Okay, we still need some variant testing. So basically I probably change this. Like after everything is working, I probably further refine that. So if this open somewhere. Ah, here. Did I want that or I wanted that? Further refine arch matching for PowerPC 64 LE, for example. So there will be some variants. So we leave that in here because we, oops, we also didn't, is this here power? LE. So risk 532, did we test that? I think our name is just risk 5. Okay, some is not yet available, the other initial stuff works, amazing. So there was only Word, do we have Word there? We have Word for all, amazing. Word for both, look standard. S390X IBM mainframe, certainly needs some most testing. S390X. Okay, the initial user space stuff probably still building on the kernel. Past not yet available. Okay, this is also illegal instructed here for some strange reason. So for Spark we need... not really sure if we need that one here, but maybe we do that. At least we need the Spark Station 5. Not sure what is the default. PRX. So that is Spark. That is annoying. We need to make sure that those quotes pass through here. That is always a little bit tricky. Maybe it just works already if we're super lucky. Okay, passed. Other stuff still building or failed? Alright, it failed on CMake. We can actually touch this log already, probably. So need some automated way to skip CMake for some... The problem is we need CMake for the cross-compile. Also wait, this failed differently. It might fail. Yeah, it fails. I just add this for another architecture already, just before the live stream. So yeah, 20, this is super silly that like this, like if it's not available, like just don't do it, because now we need to hard code it here for if old stuff's in no year 2038, it's like you had one job, but yeah. Did we run some of this doesn't match yet. Why does this not? QEMU. Did I script that wrong or not? Ah, here's a star missing. Ah, here's also a star missing. Ah, here's also a star missing. Yeah, we just changed it earlier. So, okay, maybe couldn't open Super Spark, so this does not work here, unfortunately, yet. This can certainly be made white space clean another day. I think let's try like basically to do that eventually. Maybe not this live stream. Okay, kernel is not there anyway. Good, I guess we prepared that. That's probably, I mean, maybe we need more memory, whatever the default memory might be. But okay, if it's out of memory, we fix this later. Maybe. Spark 64, probably don't have the kernel there yet either, right? Other stuff starts to work, that looks relatively straightforward. So that needs MR2D, not joking, that's a thing. This needs even more crazy stuff, that needs that and that. So what was it, Super H? I believe it's QEMU system SH, right? SH4. SH4. Console. Oh, this is append. Do we have append? Yeah, append console. Okay, this is not level we don't need. And QEMU args-m. This is some Renesas 2D development kit thing. So what was our name? Our own config was probably Super H. Also somehow not. Ah, right, this failed early. Okay, it failed early. The only constant is change and regressions. So Mirza previously asked, so it seems logical, if I understand correctly, you plan to load an Arch-specific ISO inside an emulator and run generic tests. Not only the emulator, so two folds. We start with faster because booting whole ISO is super time consuming. So we run some even through user space testing. With the benefit, potentially we could later use other user space emulators like Itanium's Sky. And so these are two different things. Like some sets of we can lightweight, higher performance run that. Theoretically, we could even later do this with secure shell Unreal architectures if we really wanted to. Like basically further making this test more generic and so that they can transparently run in QEMU or secure shell. And yeah, some will be here in whole ISO booting. So basically also testing that the whole ISO boots. And it is one test, like does it stuff even boot in its designated environment like PowerMac or because some kernels only boot on one thing like Super H, right? Only supports in this board. It's like to something we done company, although not at a level like this. So yeah, industry leading here, recurrently just maybe a little bit late, but industry leading. It's like I don't know of other Linux distributions automatically test their stuff, but no, we do. So so that we tested right, it probably should work. Yeah, we later want to export. So later we would want to test that this works with i486. I guess we have done so that is anyway trivial. We run it like this daily. What we also want to detect. So probably we wired up most now. We probably don't have enough yet for Spark. Just continued. Oh, from now the first test pauses there, sweet bit further. We could speed this up a little bit. So basically we would need to check our system. What was it? PAR U? Architecture, processor, PI. Okay, we can also just use I as Annehmer, thank you very much. There is no arch. Was there not an arch thing? Oh, come on. That. So basically, we could just hard code when to use KVM to speed this up. What would be the best? I mean, the best thing would be to compare. I mean, okay, we have actually Arch. You know what? We have Arch here, right? Previously, I think we had Arch in so what we would need to compare is just our Arch is slightly different, right? Is our Arch, it's probably this Arch is from our internal. It's slightly different for readability, not to get completely insane. The thing is, it makes it, I mean, the thing is, even the Linux kernel names some things differently than, like the Linux kernel also uses ARM64 when a lot of other things uses AArch. So even if we would use other names, it would still not match in all combinations. What we would need to check here basically, so host arch here is that arch, then, I mean for now we could custom check like if host arch was dash m, right? I mean, we could even theoretically, I mean, for now it needs to work, and making it more generic can be later, but if host arch equals x86-64, then qemu args, where do we have qemu args? And similar for like PowerPC, if what is the power? Is it power? Is it long or short? Maybe it's short, right? If that is PowerPC 60, do I have a PowerPC? I mean, ironically, we can run that through qemu here. Alright, we can't run that through there. That's unfortunate. That's unfortunate. I mean, I could change it later. What would be... I mean, we have some script here in uname translation. So uname to arch is, yeah, PowerPC, so uname should be short form. So uname does not even agree with arch triplets, right? So this is why we have chosen some middle ground of readable common sense things. It's like uname PPC, arch triplet PowerPC. Anyway, so if that is PowerPC 64 and ARM, we also have, should we do this first? So we reset it there, right? Okay, first that, then do we have that there too? So if we run on PowerPC 64, theoretically I could also, this is also Arch, it's probably Arch, right? Yeah, Arch 64, because of course it is. If you can name something stupid, then ARM does. Theoretically, we probably want to further refine that, but at least some start of potentially enabling that. It's not like someone does anytime soon run it on PowerPC 32 or stuff. What? Which build was alpha? No, WebKit fails again for alpha. Share, like, and subscribe if you want me to fix even more of these build errors. Maybe we should not even. Ironically, I packaged WebKit GTK just to have some fallback browser, and then the bloody fallback browser also is so complex that it often doesn't build anymore. So, yeah. That's basically it for this test live stream. I think we scripted most things. We can give it like minimal things missing. Let's do that one more time and see what kind of last minute errors we find. And yeah, it even found P80 legacy oopsing the Linux kernel, right? So much for that. Certainly better than someone experiences in practice. There's of course so much more we can do, right? Testing, network booting, NFS root, and so on and so forth. So the first step's always the most time consuming, and then copy and pasting test cases and adding more is of course the easy peasy part then to do later. So yeah, also I probably should restore that. Maybe I try that. That is a win-win. They just removed that recently. What was it? Was it they have long? Do they have long? They have short names. Okay, more PowerPC 64. What was it? ABI 32. Here, unless you want to enable, it is only enabled for the targets for no original. But I put, what was that here? Because they removed it. Oh, this is 2007. Thank you very much. Um, 2017, yeah, the last years, like they found a bug and then removed it as per usual. Oh, this is ARM. I need PowerPC though. Damn it. Was it even named that? I believe I documented. Okay, the test runs. Oh, this is NAT, not a thing. Certainly nice quality of life improvement. Not to see so many errors. So how many did we? I didn't test all. I only tested the most popular, as I now have more popular mainstream and all of it build configurations. I hope it's a small patch, like maybe we can ship it and mostly works. At least some testing is better than no testing. If upstream doesn't want it. Can QEMO be removed? Oh, freaking what is wrong with people? I added it to some to do. Here, ABI 32. Deprecated features, ABI. Has a number of issues which regularly trip up for... It's like here, it sometimes finds some issues like due. I mean, it's not that difficult, right? For that reason, nobody actually used it here. Is it still in there or not? Can you enable it somehow? Maybe we need to... Okay, maybe it's... I mean, let's hope we are so lucky it's just not enabled by default. And we can just enable it. But knowing them, it wouldn't surprise me if they deleted that. Is it 8.2? There's a release candidate. Had it not extracted. Here they say deprecated and removed. They don't say the same here. Let's see what we find. Yeah, by 2024 you think Google is amazing and it doesn't find anything anymore. Removed features. Thank you very much. It was removed. Has had a number of issues, so removed in 7.0. No one actually used it. I was using it. It was fine for me, right? It's like some people, there's some small issue, right? Like nobody's using it. I'm like, no, I was using it. It was fine for me. Like, I don't know what all the fuss is about. Like people nowadays, small issue deleted. It's like due. It was working fine, man. Anyway, I probably say I need to diff that somewhere. It's remove deprecated. Oh, here's finally. If we are lucky, we can just revert that. So this is remove deprecated 2021. It's likely broken. It was working fine for me. So let's remove this now. Since this is entry deprecate type, let's remove. I mean, this small thing, like seriously. Really not much code freaking. Yeah, Red Hat, they really hate open source. They only are happy if at Red Hat they're only happy when they delete source. Anyway, let's make a note so next time I don't need to Google for 5 minutes. I will probably try to restore this. Copy and paste every second time. Thanks to Red Hat's superior Wayland. So what broke here, so not yet available, that is ARch64. That says not built enough. Okay, we have here also multiply. Which one was it? I mean, maybe it is, right, Kling. Yeah, okay, Kling did not yet build. Need to fix, and yeah. Some Kling fix there, some TARC work there. Kmod is also segmentation faulting with Musel. At the end of the day, all this stuff keeps you nicely busy. But now we have a freaking test suite, and I can run it and see instantly what's still broken and missing. So Neos, this is X32. Do we not have a QEMU? Okay, we really don't have an X32 thing. That's unfortunate. We don't have an init RD yet. Yeah, I probably, you know what, let's, as a very last thing, but then of course we worked already, an hour or two open source work a day keeps the increasingly best Linux distribution maintained nicely in order. And let's, as a last thing, check the Linux kernel availability to make this even nicer for not yet kernel builds. So that would be in generic QEMU of VM Linux. So test exists. What do we, basically that, right? So this root test if there is a, what even, let's 900 best. Slow is faster. So this root here, let's this root that. If exists this root, VM Linux, otherwise exit 42 is this root, root VM Linux, or not yet. Yeah. Let's see, does it still work? Okay, x86-64 did. So it's this running through KVM, so instant, even faster continuous integration improvement, right? Nothing like wasting millions of user space cycles. Like here, like a difference of den, like KVM, like 1 second we booted. QEMU, 12 seconds at the edge of a timeout. Yes, we finally tiny code generated that and code morphed that. TUI, right, they will remove everything they don't use. Yeah, exactly, that makes me very sad. So yeah, that apparently looks fine. So some tests, so yeah, x86 apparently, yeah, x86 fully built, of course. Yeah, next we would need, it's like, yeah, this is probably PowerPC, we saw that earlier. Like, the only substitute for testing is more testing, right? And that's what we do here. And that is why increasingly T2 is not only the all CPU architecture supported and everything other people delete often restored, but the most tested, here, past, not yet a thing. Past, that is fine, not yet a thing, not yet there. Maybe I should change not applicable to not yet supported. There's certainly nuances and not, it's like, yeah, past, not yet a thing, like S390X, right? And not yet there. Amazing. Certainly an even better, like if you run all tests and half your stuff is not there and you have lots of diff scrolling by the, that is certainly what is there. There's even, look at that, it found another, like long arch, apparently, error while loading shared libraries. So that is exactly like, am I making this shit up? No. Chinese code quality, expected PLT relog type 00 of, okay, maybe long arch does potentially maybe not work. Good that we found that out. What is all of that? Is this also long arch? Yeah, that is long arch. Do we have that of init RD, not yet there. Do we have even QEMU system? Okay, we have that, doesn't work, cool. That is certainly a nice closing here. more progress, more testing. Hope you enjoyed this, learned something. We make certainly progress in YouTube live streams every day. Hope you enjoyed this, learned something, especially the only constant is change and regressions, and the only substitute for testing is more testing. Maybe go write some tests, fix some bugs. Enjoy your day, have a good day or night, and I hope to see you soon for subscription, maybe token of Patreon appreciation, downloading T2 releases, and see you soon for the next live streams. And increasingly cool stuff, right? Like now that everything nearly works, we can actually write a test suite and continuously integrate it and share it with all of you. See you next time.